Welcome to another part of the ISM Exercise Set Microeconomics, this time with a unit on monopolies. Let's have a look at the exercise. Here we have a company is the only supplier active in a market for winter jackets. Its cost function is 2.5x squared plus 18, and the demand for winter jackets can be described by the following demand function. That's minus 1/2 x plus 72. Our tasks now with this: first, calculate the profit maximizing output of the monopolist. B, calculate the monopoly price. C, calculate the profit of the monopolist. And finally, how high would price and quantity be if there were competition in the market? Okay, before we can start with any of the four parts, we need to do some preliminary work. That means we have to get our marginal costs and our marginal revenues. Well, the marginal costs, that's still very easy. It's just the first derivative of the cost function. So we take this, take the first derivative, and well, that's only basically the first part where we have 2.5 times 2 and then x. The 18 is omitted because there's no x there. So we get marginal costs of 5x. For the revenues, we can now directly start because they're given as P equals 2. So they're already solved for P, for the price. If this weren't the case, we first have to solve the corresponding demand function for P. So if we have this here, we can just get our revenue function by multiplying the demand function with the quantity. So we have quantity times price. Only the price is actually given via the demand function. So here we have x times and then parentheses the demand function. Then we factor all of this out, get the 72x minus 1/2 x squared, and we only have to take the first derivative thereof. So here again we have 72, the x is omitted, minus 1/2 times 2x and then to the power of 1, because there's 1 subtracted from the 2. So we get here 72 minus x. Then we have already all the preparation done which we need to be doing, meaning we can start with part A, the profit maximizing output. And for this, we just equalize marginal costs and marginal revenues. So here we have 5x being equal to 72 minus x. And then we solve this for x. So we go plus 1x, having 72 being equal to 6x, divide by 6, and get a profit maximizing output of 12. That's already all there is to this first part. Then the next step, we have to take this quantity, which we just calculated, can, for the monopoly price, insert this quantity into our demand function. The demand function, if we recall, already was like P equal 2. So if we insert this, we get a price. Why do we have to insert this in the demand function? Well, the monopolist first decides how much he should produce to maximize his output. And then he takes a look, what's the maximum price he can charge the consumers? And that's what we get from the demand function. So, as I said, we take the demand function, 72 minus 1/2 x, and we insert the quantity, the 12, so we have 72 minus 6. This gives a monopoly price of 66. So we have monopoly quantity, 12, and monopoly price, 66. With these two information, we can then start working on the monopoly profit, because that's basically revenues minus costs, and the revenues are quantity times price. And for the cost, we just insert the optimal quantity, which we calculated in A, into the cost function. So we get here 12 times 66, the revenues, minus, then we insert the 12 in the cost function. So we have 2.5 times 12 squared, or 144, plus 18, giving us here a monopoly profit of 414. And well, that's already part C. So we are only left with part D, the polypoly equilibrium, or the situation, how the market would look like if we actually were having competition. And for this, we need to recall that the polypoly equilibrium results from equalizing supply and demand. Demand function, well, that's what we already have here. And the supply function, for this we just recall that supply results from the marginal costs. And well, we already also calculated the marginal costs. So what we're doing here is equalize marginal costs and demand. So we take here 5x equal to 72 minus 1/2 x, and we solve for x. So we go with plus 1/2 x, giving us 5.5x equal to 72, and we divide by 5.5, giving us here a polypoly quantity of 13.0909. This already looks pretty well, because the polypoly quantity always needs to be larger than the monopoly quantity. Here we are 13 something, in the monopoly we are 12. Okay, we are only left with the polypoly price. Well, for this we just insert the quantity we just calculated either in the marginal costs or in the demand function. Here in this case, marginal cost is a bit easier. So we insert the 13.0909 in the marginal cost, getting here 5 times 13 something. So a polypoly price of 65.4545. Again, we can check whether this looks correct. And for this, we need to recall in a polypoly, the price is always lower than in a monopoly. Okay, here we have a monopoly price of 66, polypoly price of 65.4545. So yeah, check this as well. And then, well, we already concluded the fourth and final part of this exercise. And I hope you enjoyed listening to it so far. And if you're looking for more exercises, feel free to visit either the rest of the exercise set or have a look in the corresponding playlist. I say goodbye and see you next time.